Hi, I'm Tom Nahomi from Dell EMC. In this demonstration video, I'll be showing the new Dell EMC PowerFlex CSI driver version 1.3 and presents its new features and capabilities. PowerFlex fundamentally consists of three types of software components: the storage data server, the storage data client, and the metadata manager. The storage data server is installed on every node that will contribute its storage to the system. It owns a contributing drives and together with the other SDSs forms a protected mesh from which storage pools are created. The MDM hands out instructions to each SDC and SDS about its role and how to play it, giving each component all the information it needs. The storage data client allows an operating system or hypervisor to access data served by PowerFlex clusters. The SDC is a client-side software component that can run natively on multiple operating systems and is optimized to use multiple networks and endpoints in parallel. As you can see, I installed a new OpenShift 4.6 cluster. By navigating to the Compute tab, we can see that the worker nodes are running RedHat CoreOS. By default, OpenShift runs on CoreOS, which is a fully mutable operating system that is delivered and installed as a component of OpenShift. And as a result, until now, it wasn't possible to install the PowerFlex SDC component on CoreOS worker nodes, and RHEL compute nodes were required to deploy and use the PowerFlex CSI driver. Starting from OpenShift 4.6, the strategy of bring your own RHEL nodes is now deprecated, and support for using RHEL compute machines is planned for removal in a future release of OpenShift 4. One of the highlights of this CSI release is the SDC init container. We've made an architectural change in the driver during the CSI installation, and now it automatically deploys the SDC component as a container on each CoreOS compute node, so that users can now use CoreOS compute nodes to consume storage from PowerFlex clusters using the new CSI driver. With that, let's install the new PowerFlex CSI 1.3 driver. The first step is pulling the latest driver from the official GitHub page. Then, we need to create a new namespace for the driver. As part of the installation, we need to create a secret file for the PowerFlex credentials. The values are encoded with base64. The next file we need to create is the values file. Here, we specify the PowerFlex details such as system name, gateway IP, storage pool, and MDM IPs. Now, I'm running the installation script. I'm specifying the namespace and the values file I created earlier, and I'm also specifying the snapshots flag to enable snapshots functionality. The installation script is running verification steps and deploying the CSI controller and CSI nodes on each OpenShift compute node, as well as the required sidecar containers using Helm. If we navigate to the OpenShift UI, we can see that the CSI driver pods are now initializing. In addition to the driver and registrar pods, we have an additional new init container, which is used to run the SDC on that node. As you can see, within a few seconds, the driver is up and running, and this means that the SDC component is functioning and can access data served by the PowerFlex clusters. As you can see, there are currently no PVCs in my cluster. By navigating to the Storage tab, we can see the new VxFlex storage classes that have been created. Now, let's create a new PVC from the PowerFlex storage class. I set the storage class to VxFlexOS and the size to 32 gigs. As you can see, the volume hasn't been created yet, as the volume binding mode is set to wait for first consumer. This feature was added in CSI 1.2 in order to provide topology awareness. So now, let's create a new demo pod with a claim for that PVC. As you can see, as soon as Kubernetes is receiving the request, a new volume is being created and mapped to the worker nodes running this pod, using the PowerFlex CSI driver. If we navigate to the PowerFlex UI, we can see that a new volume representing the persistent volume has been created and mapped to the OpenShift CoreOS compute node. Starting from version 1.3, the PowerFlex CSI driver supports volume cloning. This allows specifying existing PVCs in the data source field to indicate the user would like to clone a volume. A clone is defined as a duplicate of an existing Kubernetes volume that can be consumed as any standard volume would be. The only difference is that upon provisioning, rather than creating a new empty volume, the PowerFlex creates a read-write snapshot which is exact duplicate of the specified volume. The source PVC must be bound and available. Source and destination PVCs must be in the same namespace and have the same storage class. To clone a volume, we need to specify the source volume under the data source parameter. And of course, the size and the storage class name must be the same as the original volume. Again, this volume won't be provisioned until we create a new pod. So let's create another pod with a claim for this volume. As you can see, both PVCs are bound and the new pods are now up and running. If we go to the PowerFlex UI and click on the source volume, we can now see that a new read-write snapshot has been created, which is basically our new Kubernetes persistent volume. Starting from OpenShift 4.6, volume snapshot views have been added to the UI as a tech preview, so now, in addition to the OpenShift storage objects, we can view, edit, and create volume snapshots directly from the UI. I really hope you find this demo useful, and thank you very much for watching.